All right, we're going to solve for example 4 in the book in section 5.1, although this is, again, slightly different than what appears in your book. All right, again, I want to caution you that when you plot a system of equations by graphing, it is wise to use the slope-intercept form of the equation, because it will screen out special cases right away, which is useful, which you might not otherwise see unless you go all the way to plotting on graph paper, and that would be tedious, more work than it's worth, trust me. Alright, so let's look at equation 1. Oh my goodness, equation 1 is already in slope-intercept form, where m, or m1 since it's slope 1, is minus 4/3, and b1 is minus 1. So without any further ado, I can actually plot this, or at least plot a sketch of it. Oh, here's my x-axis, here's my y-axis, and somewhere down here, right, is b1 equals minus 1. So that means that this point here is going to be 0, minus 1, and my slope, m1, is going to equal minus 4/3. That equals the change in y over the change in x. Alright, so my change in x, here's 3. That's my change in x. So I'm going to add 3 to my existing x. 0 plus 3 is 3. And here's my change in y. It's minus 4. So I'm going to subtract 4 from my existing y and get minus 5. So here's my second point. That's going to be down here somewhere. Oh, wait a minute, 3. Yeah, 3, positive 3, negative 5. Down here. So this is 3 minus 5. Oops. Minus 5. Connect the dots. And it's going to look something like that. Okay, so it's mostly it's negative. Not a problem. We already knew this. All right. Well, unfortunately, equation number 2 is not so readily apparent since it's in standard form. So we convert it to slope-intercept form. Not a big deal. So we start by copying it over. 8x plus 6y equals minus 6. Okay, let's get rid of the 8x by subtracting it on both sides. That goes away because it's 0. That's 6y equals minus 8x minus 6. So we're going to subtract 6 from both sides. 6 over 6 is 1, so that becomes y, since 1 times y is anything. 1 times anything is anything, so all we have left is y. This becomes minus 8/6x minus 6 over 6. We can simplify this. 2 goes into 6 3 times. 2 goes into 8 4 times. So this is minus 4/3 x. And 6 over 6 is just 1. Uh-oh. Why does that look familiar? It looks familiar because it's exactly the same as this guy. First equation. Here's our first equation. Okay. And if we go down here, I'm sorry to take you off screen, this is exactly the same as this equation. Alright? Here. And here. Same thing. So if we were to plot it, we would just end up plotting a line that would go right on top of the existing line. So we end up with one line, and since we have one line, there are infinitely many points we can put on this, so there are infinitely many solutions. Infinitely many solutions. Okay, what you should do now, of course, is what I've been suggesting all along, is go to the book, turn to page 285, take a crack at doing this example before you look at the detailed explanation of the solution that's given by the author. Good luck.